Evening everyone, I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hamper Kliman. And of course, if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share. We have been on a series on binary operations, and of course we are trying everything to make everything simple. If you have challenges in mathematics, physics, chemistry, or mathematics, ensure to inbox me on this particular WhatsApp line. Okay, on the WhatsApp line, which I'm going to write on the screen, which is going to be a plus 26077664046. This is my WhatsApp number. Inbox me and I'll be able to respond to you. We go back to our question. The operation star on the set of real numbers R is defined by A star B equal to the open bracket of 2A minus 3B to the power 2 minus 5B, where A and B are members of all real numbers. The first question is saying, is star a binary operation on R? And I mentioned in my previous session that a binary operation is just some form of a rule. It is a rule which simply states that for a given set, and that set might be a set of real numbers, suppose you get two elements, A and B, then you apply an operation which could be a plus or a minus or a multiplication. You should be able to get a single element, and that element should be a member of the given set family. So in this case, if we find that single element, that element should be a member of all real numbers. So we try to answer the first question. The first question is saying, is star a binary operation on R? So we have been given A star B, and then they are saying that this is equal to 2A minus 3B to the power 2 minus 5B to the power 2. So in order for us to prove whether star is a binary operation on R, we can simply say we let A equal to 1, then I can also let B equal to 1. Okay? Notice that 1 is a real number. The value we are to find should also be a real number, else this particular operation won't hold. So this is going to be a 1 star 1 operation. And of course, in this particular case, we know that star is simply a minus. So I'm going to replace. This is going to be a 1 there. You can just use simple terms or simple digits for your proof. To the power 2 minus 5, then 1 to the power 2. Notice that what I am going to get here is a 2 minus 3 to the power 2 minus 5. So here I am getting, okay, here I'm getting a, this is going to be a negative 1 power 2 minus 5. So this is going to be what is negative 1 to the power 2. It's going to give me 1 minus 5. I'm getting negative 4. Notice that negative 4 is a real number. Negative 4 is a real number. Henceforth, star is a binary operation on R. Therefore, star is a binary operation on R. That is how you do the first one. Let's try to do the second question. The second question is saying we determine whether star is commutative. Remember, in my previous session, if you are to prove that star is commutative, then the rule simply states that A star B should equal B star A. So you can say this is our left hand side should equal to our right hand side. So let me try to work out my left hand side here. So I can say left hand side. So if this is my left hand side, then A star B is going to equal to, we have been told that it is equal to 2A minus 3B power 2 minus 5B to the power 2. Let's try to expand this. So we are going to have 2A minus 3B multiplying 2A minus 3B, then minus 5B power 2. 2A multiplied by 2A is going to give us 4A power 2. Then 2A multiplied by negative 3B is going to give us negative 6AB. Then negative 3B multiplied by 2A is going to give us 3. It's going to give us a 6AB. The negative 3 multiplied by negative 3B multiplied by negative 3B, that is going to give us a plus 9B to the power 2 minus 5B squared. So if we expand this, we are going to have 4A to the power 2 minus 12AB, then this is going to give us a plus 4B. This is what we have on the left hand side. Okay, let's try to check if we are going to get the same value, okay, if we interchange them. So this implies that if we were to have B star A, this is going to be equal to, this is going to equal to so this is going to equal to, we can interchange everything we see. So there we're going to have negative 3B, then of course we're going to have a plus 2A power 2 minus 5B to the power 2. Okay, so because this is B star A, so this can also be written as, we can interchange, we can get this thing and take it there, and then we can get our expansion. Okay, we put it here. So if you are to expand this, you still get this particular equation. you discover that what you're going to have on both ends is still going to be the same. Henceforth, we can therefore conclude that star is commutative. That is how you prove the first one. We try to do the second one where they're saying we determine whether star is associative. This is where a lot of people tend to have challenges, but we shall work it together. Let's clear the board. How do you prove whether star is associative? The second question, we determine whether star is associative. The rule simply states that A star B star C must equal to A star B star C. That's what the rule simply states. So we need to have the left hand side equaling to the right hand side. Let me try to work out the left hand side here. So the left hand side is simply saying A star B star C. We can use Z concept where we say let A star B equal to Z. So I can say Z star C is going to equal to, notice that when we expanded A star B, we're getting something like 4A power 2 minus 12AB plus 4B squared. So when we make an operation star between A and B, we are getting this particular equation. Hence, when we make, so this one is going to represent our A, this is going to represent our B. So when we make an operation star between Z and C, in the same equation, we are going to get 4, then A is going to be replaced by Z power 2 minus, then we're going to have 12, then where there is A, of course, I put a Z, then where there is B, I'm going to put C, then plus, then 4, where there is B, I'm putting a C. So this is going to be 4C to the power 2. Then we can do our replacement. So we can say 4, comma, notice that Z, we equated Z to be equal to this, and this is equal to that equation there. So I can replace my equation, and I'm going to have 4A to the power 2 minus 12AB plus 4B power 2, like that. Okay? Then remember that Z was to the power 2, so I can put my power 2 there, minus, this is going to be 12, then open bracket, Z is simply 4A power 2 minus 12AB, then plus 4B power 2. Then we are multiplying with C. Okay, so multiplied by C, and then plus 4C power 2. So this is what we are getting on the left hand side. Let's try to do the right hand side. So right hand side is star is going to be A star B star C. Now, we can use the same Z concept. We let Z equal to B star C. This implies that A is going to be an star is going to be an operation between A and Z. We can use the same concept because when we do an operation A star B, we are getting this particular equation. So henceforth, if we do an operation between A and Z, in the same manner of the equation, we are going to replace. So this is going to be our A, this is going to be our B. So what there is, of course, it's going to be a 4A power 2 minus, of course, where there is A, I'm going to put A. Where there is B, I'm going to put Z plus 4. Where there is B, I'm going to put my Z. Okay, so this is going to be Z to the power 2. Now, this is going to be 4A power 2 minus 12A. Now, notice that Z was this particular operation. So, since we have an operation B star C, we can do the same thing that we are from doing. So this is going to be considered as our A, this is going to be considered as our B. Okay, in the same manner of the equation, we are going to say 4A to the power 2 minus 12. Where there is A, where there is A, I'm putting a B, so this is going to be a 4B. Then where there is 12, this 12, of course, where there is A, I'm going to put a B. Where there is C, I'm going to put, where there is B, I'm going to put a C. Okay, plus, then I'm going to have 4. Where there is B, I'm putting a C to the power 2. So this is our B star C, and we made it equal to Z. So where there is Z, I'm going to replace with that equation. Okay, then plus 4. Where there is Z, I'll still replace that operation again. Okay, so when you check properly, you discover that this side, the 4 was multiplying on this particular end. Okay, we've got a 4 multiplying on that particular end there, and then this side, let me check properly. So you're supposed to do your comparison properly. Okay, so you discover that this 4 is multiplying what is in there. The other 4 is multiplying what is in here. But when you check, you discover that here we've got a 4, here we've got a B, here we've got a 12, here we've got A multiplying by B, here we've got B multiplying by C. In other words, if we let A equal to 1, B equal to 2, C equal to 3, and we insert it in this particular equation, we won't be able to get the left-hand side equal to the right-hand side. You can prove, okay? You can use the numbers I mentioned. You insert them, you discover that you won't be able to get the 2 because this particular equation here, which I have found here, is not the same as this one. Henceforth, left-hand side is not equal to the right-hand side. They will give you different answers. So, in conclusion, star is not associative. That is how you prove associativity under binary operations. Okay. Now, if you have been given to find or to evaluate 3 star 2 star 5, what exactly are you supposed to do? Well, you are supposed to use the first equation which you generated from this. That's the one you're supposed to insert in your figures. So let's try to wrap the board. Okay, so where is my equation? Of course, so this is the equation which I'm wrapping, and I'm using the equation on top. Binary operations are very simple. You don't have to master anything. You just have to understand the concepts. All right. So the equation I'm using is the one which I have marked. That's the equation we always use. We can now try to work out the other one. We see what we're going to get. Okay, so we can say the equation we're using is this one. So we can say let z equal to 4a power 2. This is a complicated expression already, so let's try to simplify it. Then 12ab plus 4b power 2. Okay, so if we let the question is saying we evaluate 3 star 2 star 5. Okay, so of course this is going to be my A, my B, my C. So let me find Z. So Z is going to equal to 4. While there is A, I'm going to put a 3 to the power 2 minus. While there is A 3. While there is B, I'm going to put a 2 plus 4, then 2, power 2. Let's try to calculate this. So we have 4, then 3 power 2 minus 12, then 2, then 3, and then we have plus 4, open bracket 2, then okay, so we're getting a negative 20 there. Now, if we were to simplify this equation, we are going to get a 4. This part we already, that part we already changed it with z. So this is going to be, of course, we're going to put a z there, like we mentioned, power 2 minus 12. Then we put a z here, then multiplied by c plus 4c power 2. So we can say 4, while there is z, I'm going to put negative 20 power 2 minus the negative 20 multiplied, what is c? C is a 5 plus 4 minus c is a 5 power 2. Let's see what we're going to get. So 4, can punch everything at the same time. This is negative 20 power 2, a minus 12, the negative 20 multiplied by 5 plus 4 and 5 to the power 2. And here we go. We get a 2,900. That is how you calculate or find these particular operations. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.